In this problem, they're asking us to use Graham's law of effusion to not just compare the rate of effusion for two gases, but to answer a specific question about how long it takes for a given volume of each of two gases to effuse. Let's start by listing Graham's law. Graham's law says that the rate of effusion for gas 1, whatever one that is that we choose to list first, over the rate of effusion for gas 2 is equal to the inverse of their molar masses, the square root of their molar masses. In this problem, they start us off with helium, so let's start by talking about helium. It takes 4.5 minutes for 1 liter of helium to effuse. From that, we can list the rate. So we're going to do helium over chlorine. Okay, so helium's rate is 1.0 liters for every 4.5 minutes. Chlorine's rate is 1.0 liters for some unknown number of minutes. We'll call it x. But we're going to solve for that x for our final answer. And that ratio should be equal to the inverse of the two gases' molar masses. In the case of chlorine, it's 71 grams per mole because there are 2 atoms of chlorine in it. And in the case of helium, it's 4 grams per mole. That's a noble gas. So if we set this up with helium over chlorine, then the molar mass ratio will be that of chlorine over helium. And 71 over 4 is 17.75. And so we do a little crunching of the numbers, and we'll set this up down below. It's still 1 liter over 4.5 minutes over 1 liter over x minutes, and that all is equal to 4.21. Now, importantly, it's 1 over 4.5 over 1 over x. It's not 4.5 over x, because if you set it up that way, you'd end up with the wrong answer. So if we follow where we're going here, if we multiply both sides of this equation by 1 over x, that would cross out, and we'd be left with 1 liter over 4.5 minutes equal to 4.21 over x. And here, if you cross multiply, you'll end up with the right answer. X works out to be, in this case, 18.9 minutes is the time that it takes for chlorine to effuse an identical volume of helium if it takes helium 4.5 minutes.